Hello and welcome. My name is Fabian Cuevas from California Eastern Labs. I'm here to show you our Smart Energy Network demo using CL's line of professional-grade wireless radio modules. Our product portfolio consists of certified modules which range from IEEE 802.15.4 to Zigbee Pro. The module of focus for today's demonstration is the MeshConnect ZICM 357 module based on Ember's EM357 chipset. Today we will be simulating a smart energy network. From the perspective of a single-family home with a radiant floor heating system, let's take a closer look. Most of us get our energy from the public utility company. In a smart energy network, you can have multiple smart energy devices in the home, such as smart appliances, thermostats, and so on. These smart energy devices can then interface with the home automation devices, such as a water pump for the purpose of this demonstration. The public utility interfaces with the Energy Service Interface, also known as the ESI. The ESI is a gateway between the public utility company network and the home personal area network. Here we have a single-family home with a combination of home automation and smart energy network installed. There is an ESI, a thermostat, and a water pump that controls the radiant floor heating system. If the power utility company forecasts or detects a power consumption overload condition, it can then send a command to the ESI to reduce power consumption. The ESI acts as a coordinator and will then send out a request to the thermostat to reduce the power load. The thermostat will then send a command to the water pump to shut down. Let's run the demo. Here we have hardware representing our smart energy network. This evaluation board represents the ESI, the coordinator of our network. Here we have a smart energy thermostat that is a member of our network. This evaluation board represents the water pump that is also a member of our network. It has a built-in LED light indicating on-off status. Let's take a look at the graphical user interface. Here we have our graphical user interface that is connected to the ESI via USB port. Let's just say we're experiencing a cold winter and the ESI receives warning from the public utility company of a potential power overload. Since we are connected to the ESI, we can then send commands to the smart energy network. In this case, we will shed load. Here we have our thermostat with a set temperature of 72 degrees and a preset of 70 degrees for the water pump shutoff. Since the set temperature is above 70 degrees, the pump is on, as indicated by this LED light. LED on will represent the pump is on. LED off will represent the pump is off. In this demonstration, we will shed load for 1 minute and drop the set temperature by 4 degrees. In a real-life scenario, it can take minutes or hours, and the temperature drop can vary, depending on the severity of the power condition. Now that we're familiar with the hardware, let's shed load. Here you can see the thermostat dropping the set temperature by 4 degrees. And the LED turned off. Since we are dropping below 70 degrees, the thermostat wirelessly turns off the pump before dropping its temperature. After 1 minute, the thermostat resumes normal operating conditions by raising its set temperature back up by 4 degrees and wirelessly turning the pump back on. We are back to normal. The ESI can also send a command to cancel a shed load. Let's demonstrate by shedding load once again. Here you can see the pump has shut down and the set temperature has dropped once again. Let's go ahead and cancel the shed load command by clicking cancel shed load. Once a cancel command has been received by the thermostat, it will turn the pump back on and raise its set temperature back up. This concludes our smart energy networking demonstration.